Definition of simple harmonic motion.
Yes.
And you have the definition in your notes.
Yes. If object.
Wait, I'm not ready to write it. Wait. One moment. Now, okay. So part A. Go.
If object undergoing simple harmonic motion, then the force is directly proportional to the displacement.
Hold on. Simple harmonic motion.
And x, no, basically x in the direction
And acts in the direction opposite.
opposite to that of displacement.
These are in your notes, and it's an awful lot of work for one stinking mark.
What is SH?
Just ask me, tell her.
Simple harmonic
SHM, simple harmonic motion. Yeah, SHM, that's fine for simple harmonic motion. Everybody knows that. Well, they do now. You don't have to write this down if you don't want to, because it's in your notes. The definition.
Exactly.
Yeah, but it's not good because it's a lot to do for one mark.
Yeah.
So don't stress about it. I mean, 19 out of 20 is still an A star.
No.
Yeah. Okay, can we go on to the next part? Now, I need to read it.
I can read for you.
Yes, but I want to draw it too. Okay, so this one here. The level of water in a harbour rises and falls. The water is 8 meters deep at noon. So this here is 8 meters at 12 o'clock. And that's its lowest. The water is 28 meters deep when it's at its highest, which is at 6:15. And that's at 6:15 p.m. Okay. Evaluate the, right. Okay, so what's happening here is when it's at its lowest, it's 8 meters, and when it's at its highest, it's 28 meters. So, what's the distance here? 20. I'm going to split it into two parts, 10 and 10.
Why?
Because remember, well, it'll be clear later, I'll say. Right, what's the first thing I want in the question?
Calculate the period in hours.
Right, so what is the periodic time here?
It's 18.25 hours.
Nope. Don't look at me like that. You know it's not. If it's 1 o'clock now, and I say lunch finishes at 2 o'clock, you know it's not a 3-hour lunch break. It's not 1 plus 2. Yeah.
Yeah.
So what is it? Don't forget what you learned in elementary school. Yeah, I like seeing this now as well.
6 hours.
17.5.
6 hours and 15 minutes.
Yeah, but why did you need to, you didn't need to do this, okay? 12 noon.
Yeah.
Yeah. 6 hours and 15 minutes?
Yeah. 5.25. 5.40.
What's that? 5 what?
No. It's not 6 hours 15 minutes.
6 hour, 5 hour to 5. 5.25?
Huh? 25 what?
6 hours
6.25? No.
5.25.
Not 6.25.
Not 5.25.
No. 12.5. Because that's the time to go from the lowest to the highest. The period is to go from low to high, back to low. This is only half the cycle. This is, look. Look. This is one cycle. Look. Up, down. This is only down to up. It's only half a cycle. So it's 6 hours, 15 minutes multiplied 2. So it's 12 hours and 30 minutes. So 12.5. No, you still look confused. Do you remember the pendulum? The time, look, the time is from here and back. So if I said this takes 2 seconds, what's the periodic time? It's not 2, it's 4, because it goes 2, 2. So 4 in total. It's the same here. If I tell you this is 6 hours, then what's the time for this? 12 hours. So the answer is 12 hours, 30 minutes. Yeah? Yes. 12.5 hours. 12.5, because that's 12 hours, 30 minutes. Yeah, good thing I'm doing this. What's the next part? Amplitude? What's the amplitude? No, you can see it on the picture. What's the amplitude? 10. Right? And how many marks for those two parts actually?
4.
For both?
2 each.
4 marks. Not bad. Not bad at all. Why 10? The amplitude is the distance, the maximum distance from the middle. So, it's hard to see. The water starts at 8, that's the lowest, and the highest is 28. So the total distance is 20. Simple harmonic motion is motion like this. The amplitude you measured from the center. So from the center it's 10 plus and minus 10. The amplitude is plus 10 or minus 10. So its amplitude is 10. Yeah, that's the amplitude. Good. Okay. Next. Now, the next part here is they want a graph. Okay. So here is time. Now, can we look up, please? What I'm going to do is, well, what graph? Yeah. I'm going to draw 2 graphs. The first graph is so I can get the marks, but the second graph is more useful. So at the beginning, what's the height? At 12 noon, what's the height? It's 8. And then the height increases to 28, and then it will decrease down again, and it will go like this. At what time here is it back to 8?
Like 4.
Or maybe I should say, what time here?
Yeah, that was 6:15.
That's 6:15 p.m. And what's this one here? It'd be 12:30. Yeah, and then this one here would be 6:45 p.m. It'd be 18 a.m. So, my goodness, no, p.m.
Because 6:15 is PM.
Oh my goodness. Let's just leave it at 2. Well, actually, we only need to do 2 because the question actually said draw the graph for 1 period. Yeah? Okay. Now, I'm going to draw another graph, but the other graph I'm going to draw, instead of measuring the height, I'm going to measure the displacement from the center. So, for example, at the beginning, what's the x at the beginning? Minus 10. And at the end here, it's plus 10. So I'm going to use my x to measure it from the center here, okay? So let's draw the graph. Well, I think this graph is for the next part. Yeah. Okay, so this is x and this is time. Okay, so what's happening for this last part? The water is at its highest, I think it says, does it? Or, let's see what it says. A ship needs 13 meters of water to enter the harbour as soon as possible that afternoon. Calculate the earliest time that the ship will be clear to enter the harbour. Okay, so what's happening? At the beginning, what's the height of the water? It's 8. But the ship needs how much? It needs 13. So it's too low. So we want to know when's the time going to be at 13. So if I go back to my picture, okay, can someone tell me, if I measure down as positive and up as negative, what height do I want here so I can get 13? I want 13 meters. So what's this height here? Wallaby? Well, maybe it's easier. What would this be?
7. This is from there to 7. 3.
Let's all just take a moment and breathe. Okay. Right. So here to here is 8.
Yeah.
Agreed?
Yeah.
Here to here, 10.
Okay.
So you want an 8, and this here, to make 13, you want 5. So how much is this? 5. So you want x to equal 5. Okay. Now if I go back to my graph, time, x, and this is noon. At the beginning, what's x? At the very start.
8. Minus 8.
Is it?
No, minus 10.
At the beginning, the x is 10. We said down is positive, so we'll say it's 10.
Down is positive.
Yeah,
Okay.
so it'll be 10. And then what happens as time goes by? Does this increase or decrease? Decrease. And then here, x is 0. And then here, x is minus 10. At minus 10, it's at the top. How long until it's at the top? 6 hours, 15 minutes. So I'll write here 6.25 hours. Yeah? Okay, so what x do we want? We want x to be 5, isn't it? So we can use our formulas. Do you remember we have simple harmonic formulas? We have x equals a cos omega t.
Why is it 5?
Why is what 5?
Why did you choose 5?
Oh, that's the. Remember, that's what I wanted x to be, to have 13 meters of water. X to be 5. We just worked it out earlier. Yeah?
Can you solve this without graph, with the formulas?
No. I think because it's a 5, it might work out to be a quarter of the periodic time. No, it won't. No, you can't. You need the graph. Okay. Do we know the x? We do. What is it? 5. Do we know the a?
Yes.
10. Do we know the omega?
No.
Nearly, because we can say omega equals 2 pi over t. And we want the small t. So omega is 2 pi over big T. What's big T? Nope.
6.25.
Nope.
12.30.
12.5.
Yeah.
So we have 5 equals 10 cos 2 pi over 12.5 t. And what mode does your calculator need to be in? Very good. 5 divided by 10 cos inverse times 12.5 divided by 2. Alright, so what answer did you get here? Oops. Oh no. What answer did you get here? Did anyone get an answer yet for t? I got t equals 2.08 hours. Yeah?
So when it
What's the other C?
It's on the board. Yeah. I can just, you know how to solve this. We did this in maths class, yeah?
2.09.
Yeah, 2.08 I got.
What's it up?
So the time is 2:05 p.m. That's 2.08 hours after noon. There's one more question left here. How am I doing? Oh, great. I'll finish the last part and then we'll finish. Now, how many marks for this question so far?
15, 20, never 20.
It's 16. 16. The question, my picture, yeah. So, there wasn't this one, this one, this one. Yes? Yeah, because this is 2.08 hours. So 0.08, that's if you multiply this by 60, you get 5. So for example, 2.5 would be 2:30 would be the time. So I just changed this hours into time. You can multiply by 60. Okay, last part. This question, it doesn't have much calculation in it, but there's lots of thinking, and lots of English, and lots of thinking. I know these are things you have difficulty with, thinking and English.
That's the situation that you try to solve it.
And thinking in English, yes. Okay, can I do the last part, Grace? Yeah, okay, so for the last part, oops, where's it gone? Okay, so if you look up, you have little atoms, and they're vibrating with frequency of 1.2 times 10 to the 12 hertz, and the amplitude is 15 times 10 to the minus 12 meters. Maximum speed and acceleration. Oh, okay. That's actually not so bad. You know what atoms are because you all do chemistry. So they give you the frequency and they give you the amplitude. Does anybody remember the formula for maximum velocity? That's what they want first.
Yes, amplitude multiplied by
A
W.
omega. Do we know A?
Yes.
Yes. Do we know omega? We can get it because what does omega equal? 2 pi over t. And what does t equal? 1 over f. So you can get omega equals 2 pi f. 1 over f. So this equals a 2 pi f. So let's calculate. 15 times 10 power minus 12
What about this sign?
times 2. We don't need to worry about the plus or minus.
Yeah?
For this one we don't.
Why?
Because they want maximum, so they only care about the size, not the direction. If I type this in right, I got 113.1 meters per second. Okay, and what's the next part? They want the maximum acceleration. Do you remember the formula for this? KJ?
Yes.
What is it?
Minus omega squared.
A omega squared.
No. I said minus omega.
Yeah, but like I said 30 seconds ago, they don't care about the plus or the minus if they just want the maximum. They just want the number.
I see.
Yeah. Like if I said, what's the highest or the biggest, I just care about the number, not the direction. Yeah?
So why is it omega squared?
Isn't that what the formula you just gave me? It said A omega squared. What did you say?
Minus omega squared x.
Yes. And what's the biggest x can be? See what I did there? Yes? Alright, can I continue?
Yes.
Yeah. Alright. Now, do we know it's the same thing, isn't it? A 2 pi f squared. Yeah? So I get, whoa, huge number. 7.106 times 10 to the 14 meters per second squared. Yeah, well, these atoms do vibrate, but they have a lot of force. So this is the first one, maximum velocity, maximum acceleration. And if you knew the mass of the atom, you could also get the force by using F equals ma. 106. Is that not it? I think it is.
Times 10 is
14. Yeah.
Which number of
It's the continuation of this one. This is the second part C. C1, C2. So this is C1, 2.
I got 8.5 times 10 is
Ah. No, I'm pretty sure this is right. Look, this is A. This is 2 pi f. 2 pi f. And then it's squared. So here's another 2 pi f.
Wait, don't equal to that. 2 times 10 is possible.
Dang!
Damn!
Man! Forgot my 1.2. Thanks, KJ. It should be 8.527. Here. 8.527. Still a big number. Nailed it.
Level 44.
You may go. We're finished then.
Can we print double side pages from the library?
Don't know.
Jail.